The in-flight calibration of the SAS system requires that the pilot and the mechanic work together to properly set up the system. Because successful in-flight calibration is very dependent upon proper pilot technique, we asked Fairchild Chief Test Pilot Russ Bunn to outline some of the important points for the pilot and the mechanic to remember during an in-flight setup.
Okay, you need to understand that the reason you're going to go fly the airplane is to fine-tune the SAS so that when you're looking at this indicator and the needle, that the needle is pointing to the proper place on the indicator at the speeds that have already been furnished to you in the maintenance manual. Those speeds are all based on the stalling speed at different gross weights. Therefore, you need to know what the gross weight of your airplane is. The book tells you that there is a chance of your stalling and that you need to be high enough above the ground so that if you do stall, there's not going to be a difficulty with inadvertent impact. But maybe the warning is too strong a warning. The speeds that you're going to fly to are somewhat above the power off stall speeds, and you're not going to do this with your power off, you're going to do it with flight idle power. When you are at low speed in the flight idle power, you're going to have a little bit of positive thrust. Therefore, you have a good margin between the listed speeds that are in the book and the actual aerodynamic stall. There's another thing to consider, and that is the fact that the stall avoidance system is put in the airplane because the airplane does not have good Piper Cub or Cessna 150 stalling characteristics. But that is mainly when you are at your full aft CG limit. When you're at a forward CG or a mid CG, and you probably will be somewhere between mid and forward CG, the stalling characteristics are not that bad. Furthermore, in the clean configuration, even at aft CG, there's not a big bad stalling characteristic associated with the airplane. It's at the very low speed that you can get to with full flaps and aft CG where the problems exist. You mustn't worry about the stalling characteristics. You'll find yourself thinking that you don't even understand why the stall avoidance system is installed. Sometimes it's that mild a stall. On the other hand, there is a characteristic of the airplane and another reason for the installation of the SAS, and that is that in the clean configuration, with the gear and the flaps all the way up, as you slow down and you get near 1.3, a little bit below 1.3 stalling speeds, the tail of the airplane starts to buffet. And people can mistake this buffeting for an impending stall. There is a regulation that requires a limited stall warning margin, and in fact the Metro and the Merlin airplanes have too large a stall warning margin when the gear and the flaps are up. But when the gear and the flaps are down, it doesn't have quite enough stalling margin. So there's the reason for having the stall avoidance system also. Don't mistake the onset of the tail buffet as you slow down for your clean stalls with a impending stalls for an impending stall. Before you go flying, you need to be sure that you have the template installed on the SAS computer, and you need to study that template a little bit so that you understand during your flight, and you need to have one of the pots adjusted, which pot to stick the screwdriver on. It's very important that you don't accidentally turn the wrong pot, because if you turn the wrong pot at the right time in the game, you're going to have to start all over. When you turn the pots, unless you've done this a lot of times, I think it'd be a good idea to turn a particular pot a full turn the first time. Find out if a full turn of the pot made this needle travel the same direction that you turned the pot. If you turn the pot counterclockwise, the needle ought to travel counterclockwise, and clockwise it travels the other way. If you go up there and you're not familiar with the reaction of the needle and you only use a quarter of a turn or a half a turn, the next time you come up on your speed, you might not be able to tell there's been any difference. So again, start out your first turn of a pot with at least a full turn, just to find out whether or not turning the pot is going to make a difference in the needle indication. On your way out there, try in smooth air giving the stick just a little pulse and watch and see what your indicator needle does. And I'm sure that you'll see it flash just a little bit. When you're approaching the speeds that are listed in the maintenance manual, you need to do them at 1 knot per second, particularly when you get within about 10 knots of the listed speeds. Because if you don't, then you're applying some G, and the SAS vane recognizes G. When you have additional G, the stalling speeds go up and all the related speeds go up. The idea of approaching speeds at 1 knot per second is to keep a smooth, steady approach, and you're trying to keep 1 G flight. If you do it at 1 knot per second, you'll have 1 G flight. Now, I mentioned that the pilot needs to approach his speeds smoothly and at 1 knot per second, but maybe even more important is that the air quality be satisfactory. If you're in choppy air, your needle travels, and you can't do a good job of setting your indicator the way that you want it to be set. The sequence of events that are listed in the manual have to be followed, because each pot that you adjust is somewhat dependent upon what happens to the pot that you adjust also affects adjacent pots. If you go out and you set 1.3 first, and then you come back and you set 1.0, you're going to have to go back and reset 1.3. It's very important that you follow the sequence that is published in the document. Let's suppose that you're going to go out and you have a brand new computer, a brand new vane, a brand new indicator, and the whole lash up has not ever been flight checked before. The folks on the ground will already have set the computer to some canned numbers that are probably going to be very close to what you'll end up with in flight. It's not a bad idea, and it might save a lot of time, if first of all you go up and trim to the 1.5 speeds that are listed in the manual, approach the stall, read your airspeed when the stall warning horn blows, read your airspeed when the pusher occurs, and maybe you're going to find out that no adjustments of the pots are going to be required. If, though, you miss the speeds that are published in the manual, now you're going to have to go back and start the whole setup. When you set up at your 1.5 trim speed and you look on the indicator and you see that the needle is way over here deep in the green, you can be sure that when you fly at 1.3, the needle is not going to point to 1.3. It's going to be high also. So when you trim to your 1.5 speed, eyeball that thing and see if it's not pretty doggone close to the 1.5 mark, which is not really here, but it's that little tick mark right there where the E on cruise is. If you get down here to 1.1, which is the clockwise edge of the hatched area, and you don't see about 1.1 speed on your airspeed indicator, you can be sure that when you get to 1.0, things are going to be wrong there also. There is a list of 1.1 speeds in the manual, and if you use the stall slot to set the needle on 1.1 when you're at 1.1 speed, you will most likely be very, very close when you get down to the published stall speed, and when the needle is right up there straight up just before it gets into the stall area. We offer the 1.1 speeds for you folks who don't have a lot of experience approaching the book stall speed, and maybe it'll save you some time.